Hi everyone, this is Dr. Ranjani, Assistant Professor of Physics working at RMD Engineering College. The subject name which I am going to teach is Physics for Electronics Engineering and the subject code is 22PH101. Unit 2 is Electron Theories of Materials. In this unit, the topic today is electrical conductivity of the metal. We are going to derive the expression for electrical conductivity of the metal. The definition for electrical conductivity is the coefficient of electrical conductivity sigma can be defined as the quantity of electricity flowing through the metal per unit area per unit time maintained at unit potential gradient. This can be written as sigma is equal to Q by TA E. Q is the quantity of electrical charges or electricity. T is the time taken. A, area of cross section of the material, and E is the applied electrical field or the potential gradient, the voltage drop per unit length or unit thickness of the material. The unit of the electrical conductivity is ohm inverse meter inverse. After the definition, we are going to derive the expression for thermal conductivity. So the diagram shows the movement of the electrons in a metal when some external field is applied. So a metal, it has n number of electrons. Let minus E be the charge of the electron and m is the mass of the electron. The metal is connected to the applied field, that is battery. One end is connected to the negative terminal of the battery and the other end is connected to the positive terminal of the battery. The field direction of the applied electrical field is shown here. So this shows the electrons and this arrow denotes the motion of the electrons in the presence of the applied electrical field. It will be opposite to the applied field direction. It is the movement of the electrons in the metal is opposite to the applied field direction. Here, the motion of the electrons are called as drift motion and the velocity acquired by the free electrons because of the applied electrical field is called as drift velocity. It is given by the symbol V and a subscript D. When some external electrical field is applied, the force experienced by the free electrons or the Lorentz force acting on the electron can be taken as minus E into E, where minus E denotes the charge of the electron and E is the externally applied electrical field. Thereby, the force experienced by the electrons in the metal because of the applied electrical field is minus E. This makes the electrons to move in the material. Due to this force, the electron gains some acceleration. It has velocity, now acceleration. From Newton's second law, the force possessed by the electron is based on the mass of the electron and the acceleration of the electron. Now equating these two equations, minus EE is equal to MA. Then A is kept in the left hand side and M is taken to the denominator of the right hand side. Thereby we get A is equal to minus E capital E by M. Now acceleration of the electron is equal to velocity by time. That is, acceleration is equal to velocity by time. Here, acceleration is taken as drift velocity divided by relaxation time. So, A is equal to Vd by tau. We need Vd. Vd is equal to A into tau, because we are going to derive the expression for electrical conductivity, in which the current density is the important parameter. The formula for current density is J is equal to N minus E Vd. In this Vd is very important. That is why we have derived here. Vd is equal to A into tau. Then we are substituting A is equal to drift velocity by relaxation time in the equation. A is equal to E minus E divided by m. That is, here Vd by tau is replacing the acceleration. Therefore, Vd by tau is equal to minus E by m. Then tau is taken here. Vd is equal to minus E tau E by m. Then we get this equation. We know that current density is N minus E Vd, and substituting the value of or the expression of Vd from this equation, in this equation we get J is equal to N minus E. Vd is replaced by minus E tau E by m. Minus sign becomes plus here, minus into minus we have plus, and N E into E square tau, and then E by m. So we get N E square tau E by m, and then this E is taken over the denominator of left hand side. We get J by E is equal to N E square tau by m. From Ohm's law, the current density is equal to electrical conductivity into the applied electrical field. Thereby, sigma is equal to J by E. So we can replace this J by E by sigma, or even we can compare the equations sigma is equal to J by E with the eighth equation, J by E is equal to N E square tau by m. That is, J by E is equal to N E square tau by m. Here we have J by E is equal to sigma. Therefore, comparing these two equations, sigma is equal to N E square tau by m. This is the required expression to find or to determine electrical conductivity of a metal.